Hello everybody, and welcome to another one of our live sessions. My name is Mike Geig, and today we'll be talking about data persistence and saving data inside our Unity games. Now, before we begin, I do want to kind of mention a couple things. The first off is that I am in a different studio today, so I'm using all new equipment that I've never used before. So hopefully you'll see I'm on a Mac actually, and I really don't know how to use a Mac very well. So hopefully we don't have any surprises, but we should be able to keep going without any real problems. So just hopefully no technical difficulties there. Second, Twitch is acting kind of strange. So there's about a 24-second lag. And it's reset once already, just kind of during the intro. So anyway, yeah, just throwing that out there. So hopefully we have a nice smooth sail, but we will see. I have up here right now our Twitter information. If you have any questions, comments, concerns, anything that you are curious about or want to talk about, feel free to follow us on Twitter at Unity3D, at Mike Geig, which is me, at Will Goldstone, and at The Ant Ranch. Hello, everybody in chat. Hopefully you're all doing very well this evening. Yes, for everyone who loves my super loud mechanical keyboard, there will be no super loud mechanical keyboard this evening. I have a Mac keyboard, and I'm actually using a few computers because each one of these only has one monitor. So hopefully I'm able to straddle all that and kind of make everything work. So let's just go ahead and get right into it here. And there we go. Just gotta figure out how to use the new streaming software. It's not what I normally use, so hopefully everything kind of goes off without a hitch. Okay, so today we are talking about this idea of data persistence. And effectively what that means is we want to keep our data, and by data I mean things like maybe the player's health or experience or the layout of a level or how many enemies were alive or whatever, any particular data that's important to us, and how to save it from one scene to another. And then you're right, the screen is weird. So how to save it from one scene to another, and then how to save it to a file. One moment here, let me see if I can't figure out what's going on with the screen. We might be having our first technical difficulty. Let's see here. One moment, let me change over to a different. Let me go back to the Twitter stuff real quick here and see if I can't fix this. Apologize for the difficulties. I generally don't like it when that happens, but what are you going to do? It has done this weird thing. So let me see if I can re-add it. One moment, please bear with me. I know, not super exciting, but just about got it done. How is that? So, okay, so that should have fixed the issue there. Sorry about that. Trying to use Wirecast, and first time I've used the software, and so sorry about that. So anyway, yeah, it's like I said, there's like a 24-second lag. So there we go. So now you're back to where we need to be, and now it should be full screen for everybody. And there we go. So sorry about that. So let's get back on track here. For those of you who are watching the recorded session of this, sorry about that. Obviously, hopefully you skipped forward or whatever. So we're talking about this idea of persisting data, saving our data from one scene to another, and then also to a file. So I have a couple scenes set up here already. They're real basic. So I'm just going to go ahead and open this initial scene. And all my scenes is just a button on each scene. I have 2 of them. And you'll see that all they are is a button that lets me go from one scene to the next. So I'll run this here, and I just have a button. My current scene is 1. And I load scene 2, and then I go back to scene 1. So there's nothing really spectacular here. I just wanted to show you. I did this this little bit of setup ahead of time. So the quality is going to be what it is. This is obviously, if you remember back to the first time I did a live session before, like the very first one I did, we had some technical difficulties then too with that. With that software as well. So obviously there's going to be a little wiggle room, a little playing around. Sorry if things are a little fuzzy, just kind of doing the best I can. Worst case scenario, if this video doesn't work out well, I'll just do this session again at another time. But hopefully everything works out here. So you've seen the scene, and the scene just basically allows me to traverse back and forth and back and forth. And we're going to use that to show persistence from one scene to another. And so everyone kind of knows, or you should be familiar with this idea of saving data using the player preferences, right? Which is PlayerPrefs. And everyone kind of knows it, and it's a super easy way to access your stuff very quickly. And I'll just show you that real quick here. But realistically, it's not a good way to go about doing a lot of our data persistence. We don't generally want that to be the way we do things. So this is, by the way, this is just the script that creates that button that allows me to go from one scene to the next. And let me zoom in here. Interesting. So I can't, wait a minute. How do I make the text bigger? Zoom in. Wait a minute, that's that weird key and that. Okay, there we go. So I just wanted to zoom in so everyone can see the text just fine here. And so if I want to write something to player preferences, all I need to do is write, the shift key is over on this one, PlayerPrefs dot, and let's say I want to set an integer. I can just say set int. I can also set float, set string, and into there pass some name, which might be, I don't know, health, and then pass in some value. Right, and what that does is that stores the value 100 for the item health in a file, right, and that'll persist between scene to scene. And then if I ever want to get that back, I can do something like int x equals PlayerPrefs dot get int, and then again pass in health. So I don't really want to talk at great length about PlayerPrefs. That's pretty much all I'm going to really say about it, because basically, we don't really want to mess around with PlayerPrefs too much. They're not secure, right? So they're just a plain text file. You can get in there and edit it. It's not secure, and it's a bit slow. And so this is kind of probably the way that most beginners are just saving their data, but I'm going to show you a better way. And so the first thing I want to do is I want to talk about persisting data from one scene to another. And PlayerPrefs certainly works on that, or works with that. But I want to talk about creating objects that have the DontDestroyOnLoad attribute, which effectively allows us to keep them from scene to scene to scene. And so, like, say I'm a big fan of creating an object that's like my game control object, and then I just store relevant data inside my game control object, and then, obviously it stays from scene to scene to scene, and I always have that data with me. So let's look at maybe creating something like that. So let me get back into Unity here, and I have to remember where my hotkeys are on this keyboard. And so I already have these 2 scripts that we're effectively going to be creating, and I don't want to cheat, so I'm just going to delete them real quick here. Yes, goodbye. Because we're going to make those from scratch. And so the first thing I want to do is I'm going to create my game control. And so I'm going to create a C# script, which I'm going to name game control. And the idea of game control is it's going to be just basically a mono behavior class that will contain some data that I'm interested in and will enable me to to keep it from scene to scene and always have it around. Okay. Sorry if you guys are having poor video quality. I'm just reading the chat here. Okay, one of the questions is, what should player preferences be used for? Player preferences is for basically non-important data. So it's PlayerPrefs, right? So you can store your players' preferences in there, and if they get destroyed or go away, it's not that critical of a deal. You really shouldn't save like your game data, your really important stuff, because that's not, that's not what it's for, and it's not really a great way of doing it. So, yeah. Okay, so what I want to do is I'm going to create a class that is, which is game control, and it's effectively going to be responsible arbitrarily for storing a player's health and, say, experience. So I'm just going to do public float health, which I want to spell correctly, and public float experience. And the idea is that I want this object to constantly be around. And I can do that very easily by, in the start method, saying DontDestroyOnLoad and passing into the parentheses game object. So now this game object will persist. Whatever game object I put this script on will persist from scene to scene to scene to scene. So if I save this and I say come into Unity here, and create just an empty game object, which I will call game control. See, this keyboard is much more quiet. And then I'll click and drag game control on it. Oh, whoops. I will attempt to click and drag game control on it. You can see some health and some experience. I'll say give the health a value of 100 and experience a value of, I don't know, 1200. And we can run our scene, and we can see that game control is here with a value of 100 and 1200. But I can also click load scene 2, and I'm now in scene 2. It says current scene 2, and I can see my game control is still here with a health of 100 and experience of 1200. So basically, I have persisted my data from one scene to the next. Okay, so fundamentally, this is working, right? And it's kind of what we want everything to sort of be. And so, sorry, I'm reading chat here. They're just kind of, yeah. Anyway, so yeah, these videos are always recorded, so you can feel free to check them out at a different time. So this class is persisted. This object is persisted, but astutely, some of you might be thinking, but what if I start at scene 2, right? So right now I'm starting at scene 1 and game control is in scene 1, but game control is not in scene 2, right? That's correct. And so what I want to do is, and I'm also going to go ahead and delete this prefab because I created that earlier and I don't want to have it right now. And so what I want to do is I want my game control to have the ability to be in every scene, regardless of which one I start on. That way, if I'm debugging, say, scene 500, which, whatever, that's a lot of scenes, but I don't necessarily need to worry about whether or not the game control is going to be there. And so what I'm going to do is I'm going to come back to my script, and I'm going to turn this into what is kind of known as a singleton design pattern. It's not a true singleton, but the idea is that we will only have one of it, right? We'll only have one of these game objects at any particular given time. And that will enable us to kind of just put them all over the place and not really worry about it so much. And so what I'm going to do is I'm going to create a static variable that's going to hold a reference to this object. And so what I'm going to say is I'm going to say public game control, which is the type of script I just created, and then I want to make it public static. I forgot the static keyword. Public static game control, and I want to name this, let's just say control. all right, which is just basically it's a public static reference variable that doesn't really equal anything just yet. And I'm going to get rid of some of this commenting. And so then what I want to do is I don't really want to use start. Instead, I want to use awake, because awake happens before start happens, and that's what I want to do. And so what I want to say is for this script, I want to say if there is no current game control, make this the one game control. And I do that by saying if control, still getting used to this keyboard, control equals null, which means if this variable has not been assigned yet, right? If we don't currently have a control, if that's the case, what I want to do is I want to say don't destroy on load. So I don't want this object to be destroyed, right there. And then I want to say control equals this. All right, so this becomes the one object that will be referenced by this variable. So if this variable doesn't equal anything, we make this object stick around forever, and we set control equal to this. If that's not the case, if control already exists, we want to make sure that this isn't control, right? If this hasn't already happened before. So what I'm going to say is else if control does not equal this. So basically saying if control doesn't exist, make this control. If control does exist and this is not it, all right, then destroy it. Because we only want one. Oops. And I just ejected the CD drive, CD tray. So there we go. Let me put that back in there. So basically, if one game control already exists and this particular object is not it, we're just going to destroy this because one already exists and we don't want any more than one. And so that's effectively what we've created here, is we have created a class that there can be only one of, which is basically the idea behind the singleton design pattern. And so that's kind of how we're going to control this. The last thing I want this class to do right now is I want this class to have just an onGUI method so that I can see my data output. And real quick here, I'm going to go ahead and check chat because there seems to be a lot of it. Trying to just find which ones are relevant. A lot of questions that don't necessarily have anything to do with this. Okay, yeah, pretty much just explaining what singletons are. So, cool. All right, so I want to create this onGUI method, which is going to basically just allow me to output my stuff to the screen. So I'm going to do void onGUI. The shift key on this keyboard is kind of throwing me for a loop. And I'm going to say GUI.label. And my label is going to be a new rect, which will be at 10, 10, a width of 100, and a height of 30. And it will say health with an A. That's how we like to spell health. With a colon there. There we go. Plus the variable health. There we go. We will survive this keyboard, I promise. All right, then I will copy this, paste it, and my new rectangle will be at 1040 with the same width and height, and it will say experience and the variable experience. There we go. And I'll go ahead and save this. And so let's see what we have here. So I'm going to come back into Unity, and I'm going to not do anything yet. Remember, this game control still has that script on it. And I'm going to go ahead and play. And now we're going to see health and experience. Oops, I need to make my experience label a little bit bigger, as we can see here. But I have my health and my experience. And now if I load my scene, we're in scene 2 now, and this is still there. So again, nothing new just yet. And actually, let me expand out my experience to be, say, 150. So what's neat about this, the way we've made it now, that singleton design pattern, is that I can go ahead and grab my game control, and just drop it down here in my prefabs folder in the project view and create a prefab of it. And then I can come over to scene 2. I will save my scene. Now in scene 2, I can also put this game control. So both scene 1 and scene 2 have a game control. And so let's say in scene 2, I'm going to set the value to say 50 and 50. It's not going to matter because we're going to create our game control in scene 1, and then when it persists into scene 2 with the DontDestroyOnLoad, scene 2 is going to create a game control, realize there already is one, and destroy itself. And so I will come back to scene 1, and I'll hit play, and I will see health 100, experience 1200, scene 2, health 100, experience 1200, which means the other game control destroyed itself because it wasn't the one game control. All right, and we can see that work too if I start at my secondary level, right, where my health and experience is both 50, and I hit play. We will see that health and experience are both 50. If I load scene 1, health and experience are both 50. So the one in scene 1 then destroys itself. So you can see that the singleton design pattern truly allows only one object to be in existence. A side benefit of building it this way, a lot of people will create these game controls and then have all of the objects in their scene do like a GameObject.find, which is really not good. You really shouldn't do that. Or pass around references to the game control and stuff like that. And they're always trying to get to the game control so they can put data on it. Interestingly enough, since we created our game control to have a public static reference to a game control, we can just access it without referencing it, without GameObject.find or anything like that. No get components or anything like that. We can just access it. So let me go ahead, and what we're going to do is we're going to create a quick script that's going to allow us to modify our current stats. And so I'll just create a new C# script, which I'll just call adjust script. Right, like that. Let me open this up here. Oops, no. Double click it. And so adjust script is basically just going to be a giant onGUI method that's going to have just a bunch of buttons that I can use to adjust stuff. So I'm going to do void onGUI. Oops. You can do it. There we go. And this is just going to be a bunch of buttons. So I'm going to say if, and then I'm going to say GUI.button. And my button will be a new rect, which I will pass in 10, 100, with a width of 100 and a height of 30. And it will say health up. Oops, gotta end my quotes. Just like that. And so real quick, I'm just gonna copy and paste this a bunch of times. So there's health up, and then that's gonna be my health down, experience up, and experience down. And I'll go ahead and make this 140, and then 180, and then 220. And I'll make this health down and experience up. I'm just setting up all the buttons now so I don't have to mess around with the buttons here in a second. And I can show you how exactly we can modify these. Experience down. Okay, so these are just, if you don't know the GUI system, these just created 4 buttons vertically that when I click them, they're going to do whatever's inside these brackets. And so since I don't have any of the health and experience data here on this script, I would need to find my game control. But since we built it the way we built it, we can just access it. So check this out. So I can just say game control dot control. Oops, why did it do that? Dot control dot health plus equals 10. Just like that. Game control, which is the script, dot control, which is the static member, dot health, which is the public variable of the reference, the static reference to that particular object. And so then I can come here and I can just paste and make that minus equals, and then here, and then paste, and we'll make that experience. There we go. And then here, and paste again, make that minus equals, and make that experience. So there. So now again, I can't stress to you enough how important it is that this script doesn't have to do a get component, a GameObject.find, doesn't have to have a reference to it, nothing. Since the class itself has a static reference to itself, I can just access it from anywhere, and that allows me just to access it, which makes things really, really simple. And so that is all done. Let's come back into Unity. And I'm just going to go ahead and put this adjust script on my camera in both scenes. So adjust script goes on this camera right there. And then in my secondary scene, I will save that. Adjust script is going to go on this camera. And then let me come back. So what we can see is that we can just quickly and easily access this stuff. I'll go ahead and hit play. And I see my health is 100, my experience is 200, and I can just health up and health down. These buttons right here are not on the same object, they're not on the same script or anything like that, but they can just directly access and modify. And then when I persist to my next scene, that data is saved. That data persists. All right. So the first thing you can take away from this is that singleton design with the game control, and you don't need just one. You can have a bunch of them. Maybe like you have one for your player data and one for your enemy data and one for whatever, right? So you can consolidate, or you can have a bunch of separate. It depends on your game, and it depends on how you want to organize it. So you have a little bit of flexibility there. And I'm going to read the chat because you guys are chatting a lot tonight. So let's see here. All right, sorry about that. Everyone's pretty much still just talking about singletons. We can chat maybe after the live session if you're more curious about singletons. Let's see here. Why are there two cameras? There aren't two cameras. There are two scenes. Each scene has one camera. Can you only access a static reference or any others? I could access that actual object, but it's much easier just to access the static version. Okay, and everyone's just kind of talking about singleton. Yeah. So let's move on from here. Okay, so everyone's kind of talking about singletons and stuff like that, and it's not really important. You can always just rewatch this video or whatever it is you want to do. None of that is super duper important. So the next thing I want to talk about is kind of the thing that everyone probably came here to see, right? And that's exactly how do we save this data to a file to load it again later. And if you have a bunch of classes strewn about, it becomes kind of difficult. It's not difficult in that it requires a high level of skill or it's difficult in any real meaningful way. It's just difficult from an organizational standpoint of gathering up all your data and saving it, right? And that can be kind of difficult. But if you create a centralized location for your data like we have just now, I mean, obviously it's very simplified, but you get the idea. It's a centralized location for our data. We can then serialize that data and save it to a file. There's two ways to do serialization. We can do the language-specific serialization, which is what we're going to look at. We're going to look at the C# data serialization. So we can do that, or we can use Unity serialization. And Unity serialization is interesting because it allows us to build assets, and it's great for things like working with the editor and custom editors and things like that. However, it's kind of more power than we need and can be a little bit more, I don't want to say confusing. It can be a little bit more obfuscated than we need because we're basically just going to be passing things into Unity and letting Unity handle it. And we have to set things up in a very specific way ahead of time to get Unity to handle it correctly. So instead, we're going to use the language serialization, which is going to enable us to kind of be a little bit more loose with it, kind of be a little bit more easy with it. So what I'm going to do is I'm still going to do all of this through my game control. It's that one central repository of data, and I just want to keep working with that. And so the first thing I need is I need some additional libraries here that I'm not using already. And the first is using system. Oops. Using system. I also want to say using system.runtime. I don't know why it keeps putting that slash in there. Serialization. Oops. Serialization. Ugh. Serialization.formatters. .binary. Because what we're going to be doing is we're going to be writing out binary files. And the nice thing about this is that players can't modify them. We're writing out binary files, and so they are, I don't want to say they're encrypted. They're unreadable, basically, unless you know specifically what's supposed to be inside. So I'm sure a hacker or someone with a great knowledge of encryption and decryption could figure out the data that's inside, but it's light years more secure than PlayerPrefs, specifically because it is a binary file, and thus you can't just open it. So we need that. And then finally, we're going to say using system.io, IO standing for input output. There we go. So with these three libraries in tow, we can begin writing our save and our load methods. And we could put our loading in the awake and our saving in the destroy, so it just always auto saves. So I could put my saving code right here in awake, or even on start, or on enable. On enable is probably the best place to put it. You can put your loading code in on enable and your saving code on disable, and then it will automatically save and automatically load your data for you. I'm going to assume we want more control than that. We don't want it just to automatically happen. So what I'm going to do is I'm going to create a function. There we go. There's the enter key. Oh, come on now. Don't be like that, computer. Okay, and so what I want to say is I'm going to make this public, again, so other classes can make me save and load. If I didn't want that to be a possibility, I wouldn't make this public. So I will do public void, and then I will say save. All right, and save is going to be my method that saves data. All right, saves data out to a file. And inside save, and sorry here, I am just looking through chat. So someone asked, what about multiple platforms? This will work on every platform but web. So what I'm about to show you will work on mobile as well as desktop and stuff like that. But with web, we can't save local files. And so web would have to save out to a web server. So with the exception of web, this will work. Yeah. And so someone saying serialization is not secure, you can just check the monosource code for serialization. True, but unless you know what object it's cast as, you won't know how to read it. So you need to know what the object is in order to read it correctly. I mean, you could deserialize it and then just pawn through the memory. But like I said, 9 times out of 10, your general people playing your game are not going to do any of that crap. So if you need more security than that, then you're really going to need to do things like encryption and stuff like that. And you're kind of beyond what I can help you with right here and now. So, but you get the idea. Okay, so in my void save function, I'm going to basically create a file, right, and then push my data to it. And so I'm not really going to get into the rhyme or reason of what I'm doing. I'm just going to show you the steps to do it with the knowledge that this is how you do it. And so I am going to say binary formatter, and binary formatter is the thing that's going to go ahead and write for us. And I'm just going to call it BF equals new binary formatter. So we'll create a binary formatter, and then I'm going to say file stream. There we go, file stream, which I'll just call file equals file.open, which is me attempting to open a file, right? Some file on the hard drive. Now, the idea is where are we going to save this, right? Do we save it to the project folder? Where do we save it? Unity has something that's called the persistent data path, which is basically a nestled away path that we can store game-specific data that the user won't necessarily know how to get to. It's like on Windows, it's under user, app data, roaming, whatever, right? So it's kind of nestled away under a few hidden files. So we'll want to use that because that's just a nice safe place to put this stuff. And so what I'm going to say is the file path where I want to open is going to be application dot persistent data path. And I'm not just going to use that. I'm going to add to it. And I'm going to add to it a / and then we'll just say playerinfo.dat, which is the file that we want. And then my file mode is going to be file mode data.open. So again, not right now super important to know what each of these pieces does. Just know that this is how we do it. This is our file name right here. So you'd want to change this to be what you need. And this is where it's going. All right. And so at this point, we need to tell it what we're going to save, right? What data we want to put in there. Oh, 1 second here. Again, just reading chat. You guys are really chatty today. Normally the chat is fairly quiet. So let's see here. Mostly chat's not working. Sorry about that. If you're having issues, you might want to refresh the page. Okay. So one of the questions is, does application.persistentPath or persistent data path work on iOS, Android? Yes. So on Windows, it goes to a folder. Obviously, on Mac, it goes to a folder, whatever. On iOS and Android, it also goes to a folder. It might be game data on the root. I don't remember exactly where. If you ever want to know for your particular platform, you can just output this. This is a string, and that'll tell you exactly where it's saving to. So yes, this does work on mobile platforms and such. Okay, so I'm going to pause my save method here real quick because I need to have an object I can write to a file. And I can't really write this object to a file because it's a mono behavior and that can lead to some weird errors. So what I need is a clean class that will just contain my data for me. And so that's what I'm going to go ahead and create real quick here. It's going to be a clean class that's just going to mirror my data. And so what I'm going to do is I'm going to create a class, which I can put in the same file. It's not going to be a public class. It's going to be a private class specifically for this file to use. And I'm going to name it player data. Just like that. And player data is basically going to have a couple things. It's going to have a public float health. Float health. And I'm sure you wouldn't see this coming. Public float experience. Again, if you were actually making this, you'd want to do things like getting sets for all your data security and whatnot, blah, blah, blah. But we're going for simplicity here. One more thing I want to be aware of is that this class object, when I instantiate an object of this class and put data in it, is going to be what's called serialized. And serialized is basically how the system is, kind of in a nutshell, how the system is going to organize the data so it easily fits into a binary format. And so we say that this class needs to be serializable. Now, in a nutshell, the way we make a class serializable is we just tag it as such. So in order to make it so that I can write this class to a file, all I need to do is I need to put a square bracket and say serializable. This tells Unity that I, in fact, can save this to a file. So this class is done. It's just a class that is a data container that allows me to write my data to a file. So we have this container class. And so back in our save method, all we need to do now is fill an instance of that class with data and then write it to a file. And so we are going to do that by creating a new player data class. Or instantiate a new player data class object, which we'll just call data equals new player data. And you could do things with constructors and all that stuff. And standard object-oriented process applies here and good design and whatnot. But again, we're just moving kind of quickly through this stuff. And so what I'm going to do is I'm going to say data.health equals my local health. And data.experience equals my local experience. Oh, I almost typed local experience. Equals my local experience. So we're basically just taking the data from our game control and putting it in this container. And then all we need to do is we need to write that container to a file. And to do that, we say bf, which you'll remember is our binary formatter, .serialize, which is going to basically put it in a file. And where do we want to serialize it to? To the file that we created. We're going to serialize it to the file, and we are going to serialize data. So it's going to take this serializable class data and write it to our file, which happens to be playerinfo.dat. And once that's done, I just need to hit file.close. File.close. And so I'll go ahead and save that. So this is my save method. My save method creates a binary formatter, creates a file, creates a container for my object, and then writes that container to my file, and then closes the file. All right? There's a lot of steps, okay? Again, it's not super important that you know why each of these work the way they do. I mean, if you're curious, please, by all means, find out, because it's actually really cool how they all interact with each other. However, if you just need a solution that saves files, this will do it. This is a fairly canned solution that'll work for you. So that's our saving. So let's worry about loading now. And loading is going to be pretty much exactly the same way with one minor difference. So again, I'm going to do public void load. And with load, the big difference is I need to make sure the file exists first before I attempt to read it. Because if the file is not there when I attempt to read it, I'm going to get an exception. I'm going to get an input-output exception, or file does not exist exception, or one of those exceptions. But I believe they all fall kind of under input-output. And so what I'm going to do is I am going to basically, so I see here, I'm just reading through chat. I just saw a question, and then I lost it here real quick. Couldn't you use the binary formatter to send it as post data to a script to save it online? Yeah, actually, we can use the serializer to turn our classes into a string that we can pass through PlayerPrefs. I mean, so there's a lot of ability there. What we just happen to be doing is writing it to a file. So yeah, this is just a way to write it to a file, but we can use this solution to do all sorts of stuff, pass it over the internet and all that stuff. Once written, does the serialized tag apply to every class under it? So it's serializable, not serialized, just kind of a distinction there. And yes, no. So I believe that, of course, I might be wrong. It's been forever since I tried it. But I believe that every child class needs to also be serializable, because we have to explicitly give it permission to write that to a file. So I believe they all have to be serializable. Yeah, so someone in chat kind of saying the same thing there. All right. Yeah, okay. And so, all right, so we're kind of caught up on chat there. So with load, we've first got to make sure it exists. So I'm going to say if, and I am going to say file.exists, which is just going to give me a true or false to tell me if the file is already there. And of course, I'm going to type in application.persistentDataPath plus /playerinfo.dat. Oops, there we go. So we're just basically saying, hey, does this file exist? If it doesn't, we're going to not do anything. If it does, then we're going to go through our process again. And our process is creating a binary formatter, which we'll call BF equals new binary formatter. And then we are going to create a file stream, which again we will name file equals file.open. And what are we opening? We're opening application. Application.persistentDataPath plus PlayerInfo.dat. There we go. So that's the file that we are loading. And notice we don't need a file mode there since we're just opening it. And we know it already exists. And then we're going to say player data. So again, we need a container to pull this data out, which we will just call data. And player data is going to equal bf.deserialize, which is us pulling it back out of the file. Deserialize file. Now, when we deserialize, what we're doing is we're effectively creating an object. We're pulling a file out, and it's just some generic object, right? We have no real way of knowing what it is. And so one more thing we need to add to this line is we need to cast. We need to turn that generic object into the object that we want it to be. So basically, the binary formatter is going to say, hey, I pulled some object of the file. I don't know what it is. And we need to step in and say, this is a player data object, and so that we can read it. And we cast by saying parenthesis, player data, end parenthesis, just right next to it, just like that. That casts it from a generic object to player data specifically. And so that allows us to pull that out of the file. And once that's done, we can just say file.close. Because we're done with the file. We have the data. And the data is in our data class. So then I can take my local health and set it equal to data.health. And I can take my local experience and set it equal to data.experience. And there we go. That is our save and our load functions. I'll go ahead and save this. And this has everything we need to write to a file. Or I'm sorry, to write to a file. There we go. And then read from a file. All right. And again, this is more of just a generic solution. If you have very specific needs, obviously you're going to need to custom tailor this to be what you need it to be. And so the one last thing I want to do here real quick is I'm going to add a save and load button to my adjust script. So I'll just go ahead and copy this and add 2 new buttons. And this button will be at 260 and this button will be at 300. And this one will say save. And this one will say load. Load. And in my save, I'm simply just going to say gameControl.control.save. And this one's going to be gameControl.control.load. And that's it. Again, using the singleton design pattern allows us to quickly and easily access that. So let's go back to Unity now. So we did a lot of coding there. So let's run into Unity and let's see how this works. Oh, I missed something. Let's see here. Open there. Did I miss? Oh, I did miss something there. So what I want to do is, yes. Okay. So here's the problem. So I'm sorry, and I kind of got this wrong. So filestream.file needs to read file.open application persistent data path plus player info, and I also need to say file mode is going to be open. So I missed that. I forgot that. And the reason I forgot that is because up here in our save method, we do not need file mode.open because we're not doing file.open, we're doing file.create. So that's my mistake. So in our save method, it's, hate when it does that. In our save method, it is file.create application.persistent data path. And then in our load, it's application or file.open with a file mode open. So that's what I messed up there. Sorry about that. Just kind of got my notes backwards there. And so we'll come back into Unity. Now we shouldn't have any errors. Give it a second. There we go. And so let's go ahead and save this, or let's go ahead and run this. Okay, and so my health is 100, my experience is 1200. Let's bring my experience down a little bit. Let's bring my health up a little bit. All right, and so I don't think it would surprise anybody that if I stopped the scene and I started again right now, my data would be gone. So what I'm going to do is I'm going to click save. There we go. I've just clicked save. I probably should have some message that says, hey, you successfully saved. And so I'm going to just stop running my scene now. And I'll start it right back up. And we will see that our data did not persist. Okay? Health is back to 100. Experience is back to 1200. Right? Because we wrote it to a file and we didn't load it yet. Now, if I click load, you will see that I've pulled that data back out of the file and it's back into my scene. And again, I can just persist, or I can just change scenes how I want. I can increase my experience how I want, resave that, and then make more changes, and then load, and it'll come back. All right. So we have now successfully not only persisted data between our scenes, but we have persisted data to a file. And that is kind of where the important bits are, the ability to save to a file. Now, again, I can't really stress enough to all of you watching that this is one solution, okay? And, I mean, you could write books covering all of the potential ways of doing this. So if you have very specific ideas in mind, you're going to need to customize this for your own uses. This isn't just a Band-Aid. You just apply it once and it fixes everything. It is really something, that's kind of just a guide to get you to kind of go where you need to be. So real quick, I'm going to check chat here. Let's see here. So what makes this serializing method better than player preferences? I kind of covered that already. Basically, the .dat file we create is binary, which means it's really, really, really hard to edit. If I knew anything about a Mac, I would find out where that file was saved and I'd open it and show you. but I don't. So it's going to give me a string of a location, and I'm not going to know how to get there anyway. So play around with it at home. Find where it saves it, and then go in there and see that that it in fact is not what you think it is, right? That it's a binary file. Let's see here. Why create a file in every save? Open the file and change it if the file already exists. We could certainly do that. Again, this was just a real quick, simple thing. Realistically, if the file already exists when you click save, you could do the load process to pull the data out, merge the data, and then write it back, and that would certainly work. Let's see here. Would this serialization work with object references? Absolutely. That's what we create. We create an object reference, and then we write it to the file. So yes, the answer is yes. What about making multiple save files? Well, just make multiple save files. Like you see that in my script, I hard-coded a file name, but I could very easily create a GUI solution where I create a list of files and just write multiple files, playerinfo1.dat, playerinfo2.dat, and so on and so forth. So that would certainly work as well. Let's see here. Sorry, I'm just checking chat here. I talked about multiple save already. Someone has the username Mike Geig is awesome. Thank you. That makes me feel very happy. Thank you. What a great name. So yeah, thank you. What's the issue with gameObject.find? It is very, very, very slow. You should not use it because of how slow it is. Always try to have some other reference so that you don't have to use it. It works in a bind. Don't get me wrong. It certainly works in a bind. And if you use it sparingly, it can kind of almost be okay. But it's just really slow. And there's generally other ways to get references without doing it. So, yeah. Let's see here. Arrays can be serialized, but dictionaries can't. That's actually not quite true. We can serialize dictionaries if we do them a very specific way, and that's where Unity serialization becomes useful. So if we wanted to serialize and then write a dictionary to a file, we would need to create a container class called a scriptable object, and then serialize that using Unity's serialization, built-in serialization, which is a little bit more complicated, which is why we pretty much didn't go into it. All right, let's see here. Does the file have to be saved as .dat? No, it does not. That's just, you generally do a data files.dat. I could have saved it as .banana. It doesn't really matter. Whatever extension I want it's really irrelevant. You could also have no extension, but the operating system doesn't generally like that. So, yeah. Let's see here. Would this work for lists? Yes, it'll work for lists in pretty much the same way I mentioned about writing the list out to a scriptable object and then saving that with Unity's serialization. Lists and generally collections are a little bit harder to serialize. I know that they work using Unity's built-in serialization by creating a scriptable object that contains them. They may also work with the serialization method I just showed you, but I've not tested it. I've not tested it, so I can't tell you for certain. So what I showed you may work for dictionaries and lists. I don't know, but I do know that scriptable objects will work. Yeah. Let's see. Yeah, so Delta, that's what I was just talking about. I talked earlier about two ways to serialize, data serialization and the other one. I showed you the other one. I showed you the language-specific way of doing it, but Unity also has built-in serialization, which is really kind of overkill from a lot of the stuff that you're going to need, especially assuming that you're not doing custom editors and you're not creating your own assets. But assuming you are doing those things, then yeah, maybe you don't, or maybe you do need it. Yeah. Okay. So I'm pretty much going to kind of wrap up there. a lot of people are asking about the progress bar and stuff like that, but these are going to save almost instantaneously. So you're really not going to see a lot of issues there. So I wouldn't worry about that so much. But otherwise, you might need to stream it out in pieces. And again, that's a little bit more of a complicated process. But at any rate, I am going to go ahead and wrap up now. So thanks, everyone, for attending and asking questions. I had a really good chat, actually, going on there. It was kind of hard to keep up tonight. But yeah, certainly appreciate it. Thank you all very much for coming out. Again, and let me put this back up here again. If you have any questions, comments, concerns, here's my Wirecast. Any of that stuff, on Twitter, at Unity3D, at Mike Geig, which is me, at Will Goldstone, and at The Ant Ranch. Please check us out, and I will do my best to help you out. If you have questions and they're a little bit longer than Twitter can handle, always email me. You can always email me at mike@unity3d.com, and I can try to help you out there as well. Let's see here. And then chat is just chat. One more. Someone just asked about the using statements. So real quick, these are the ones you need to add. So you need to have that one. Next week is mobile. So if you're interested in mobile programming, check out next week because we're talking about multi-touch input. We're talking about accelerometer. We're going to touch on optimization a little bit, though we're going to talk about the theory and not so much the practice. And we are going to talk a little bit about screen resolutions and things like that. So next week is the mobile session, and if you want to do iOS, Android, whatever, Surface, check it out because that's what we're going to be talking about. So. All right. Thank you all very much for participating and being here and doing so much chat. And I will